Hi, welcome. This is Clemens at Elektor. In this video I will present you the 6-DOF robot arm with Raspberry Pi Pico from Makerfabs. The 6-DOF robot arm with Raspberry Pi Pico from Makerfabs is a robot arm controlled by a Raspberry Pi Pico microcontroller board. DOF is short for degrees of freedom, which, in the case of a robot arm, means an articulation. This arm has 6 degrees of freedom, allowing it to move in 6 different places independently of the others. Each degree of freedom translates to a servo. The arm is controlled by a Raspberry Pi Pico board, mounted on a small extension board that provides the connections to the servos, the power supply, a buzzer and a push button. The Pico is intended to be programmed in MicroPython, but this is, of course, not an obligation. However, the driver and examples are written in MicroPython. The product comes as a self-contained kit of parts. Besides a computer to do the programming on and a micro USB cable, nothing else is required. A 5V DC 6A power supply is included. A power cord is included too, but with an American-style plug, so depending on where you live, you may need to replace it or add an adapter. There is even a little screwdriver, but I prefer to use my own tools for assembling the arm. There are quite a few parts and even more nuts and bolts, but not all are consumed. Except for the acrylic baseplate and steel arm bone, all the parts are made from aluminium. Put together properly, you don't end up with a wiggly plastic toy, but with a strong solid metal arm. Even though everything is from aluminium, the assembled arm still weighs 1.3 kg. The robot arm is mainly an educational tool to teach programming in MicroPython. It is a fun object that can move in many ways and it can pick up small items. It is not suited for industrial applications or high-precision tasks. Assembling the arm is not for quitters. A manual is not included, but you can download one in Chinese. Unfortunately, it is not very clear and it's not exhaustive. Yet the arm can be assembled with a bit of patience and common sense, as it is not a very complicated design. The only complex part, the grip, is pre-assembled. However, there are a few things that you need to know in advance and that I found out the hard way. Be prepared to take things apart so you can assemble them again in the right way. Building it twice will probably give the best results. Start at the bottom, meaning the base plate with the rotating platform, and work your way up. The large bearing of the rotating base is in 3 parts. I notice a slight difference in spinning quality between the 2 possible assembly configurations, but in the end it doesn't seem to matter at all, as it functions merely as a dead weight. Use the red YF6125MG servos first. My kit included 3 of them, but the manual uses them everywhere. These servos are the strongest and can carry the most weight, and therefore should go on the bottom part of the arm. Make sure all the servos are in their mid position before mounting them. For the black MG996R servos you can do this manually with a kind of servo pointer included in the kit. The red YF6125MG servos, however, do not have end stops, so you can't see when they are in their middle position. I therefore ended up using the Pico for zeroing the servos on the fly, while assembling the arm. This may sound complicated, but it is actually rather easy to do. I would even suggest starting the assembly by setting up the MicroPython development environment first and trying to run the demos with unmounted servos. Once you understand how to control the servos from MicroPython, you can zero them and mount them in the arm. In all sub-assemblies, the servo goes in last. They are generally to be fixed with the screws with the gasket, the Mexican head type. Make sure to tighten everything well, as it is difficult to do once the arm is assembled. Connect the servo starting at the bottom. The lowest servo, the rotating base, 0 or A in the software, connects to GPIO 16, the highest, the grip, 5 or F in the software, goes on GPIO 21. The software allows remapping of the GPIO pins, and the spinning direction of each servo can be defined too, so you have some freedom here to correct things. The base plate has many holes, but not for attaching the Pico board or the power supply. Make sure the power supply outputs 5 volts before connecting it to the arm. The output voltage can be adjusted from approximately 4.5 volts to 6.5 volts. Do not naively assemble the arm and run the demo without having tested every servo first. The arm may spin around and move wildly, swiping things from the bench or hitting you in the face. Its servos are quite powerful. I managed to make the arm snap its own 4mm thick baseboard due to a servo pushing down instead of going up. Especially the red YF6125MG servos move pretty fast, so watch out. I therefore highly recommend fixing the arm to the bench or to a heavy plate. Also note that the red YF6125MG servos do not have an end stop and may go the wrong way around to reach their target position. This may happen when the arm is not powered and folded down. I therefore also highly recommend stretching the arm to its upright position before switching on the power. The 6-DOF robot arm with Raspberry Pi Pico from Makerfabs is not a kit for sissies. Assembling it properly requires patience and perseverance. Even though the arm is quite easy to use thanks to its driver and demo written in MicroPython, it should be tamed step by step or accidents may happen. Its servos are fast and strong and the arm is 44 cm long when fully extended. Bolting it down to the floor in the center of a square meter, void of any objects, is highly recommended. You don't want it to smash your laptop off the table, do you? Okay, that's it. I hope you found it useful or interesting, or even both. If you did, please don't forget to subscribe to our channel and click or tap the bell button. Thank you for watching.